All right, hello and welcome to the data mapping presentation from Ilya Beta. I've known Ilya for several years now. He's been an active participant in the structured data capture questionnaire space and created all sorts of cool tools and stuff demonstrated at Connect Funds and making life easier in the questionnaire space. And now he's turned his attention to data mapping, and he's going to show you the cool things that are happening in that space. Take it away, Leila.
Hello, everybody. It's nice to see all you here on FHIR. So I am CTO of Beta Software. For the last 8 years, I have been developing various kinds of applications for healthcare. My core expertise is FHIR first or FHIR native application. It is applications that leverage FHIR as a primary API. And now I am starting experimenting with building products and working on EMR solution, customizable open source, and all this cool stuff. So, but today I am going to talk about mappers, about converters, and I try to provide you an overview how you can take data in one format and transform it into another. When we are talking about any kind of mappers, any kind of data converters, there are two things that you should always think about. The first one is how you query your source data, because you have something and you need to take some particular pieces. And then the second part is how you generate the target format. And what is also important, how do you validate it? So it's two parts, and in my speech, I will refer to this two parts of the mapping. So data mapping is quite a hot topic, and this year on Dev Days, there was a lot of conversation about data mappings. There were talks about different tools, and all this inspired me to compose this talk and try to gather all software I'm used or try to use for build mappers and provide some kind of overview. Let's start with what kind of mapping could exist. First of all, we would like to provide some kind of FHIR API. Yeah, now I will be more focused on mapping in healthcare space, obviously, because we're talking about healthcare. So the first way of mappers, when we have data in FHIR format and we need to transform it in some legacy format. For example, we provide API with writability, and we need to save everything in our legacy storage. And also, it makes sense to map something from legacy into FHIR. It's vice versa operation. For example, you provide facade for your database to give interoperable API. And the third part that I will be mostly focused on is conversion from FHIR to FHIR. It may sound like some kind of synthetic example, but it is not. It is widely used type of mappers, and I will show you some examples. But let's start with first one, when we need to convert something into unknown format. So we can query source data with FHIRPath. It's pretty convenient just to query FHIR data with FHIRPath, and it's how we take the data. But unfortunately, since we are not aware of the result, you have to decide each time how you generate and validate the target data. Another approach, another type of mapper when we need to convert something into FHIR, and here we should think what should we use as a query language. And the good news is that we still can use FHIRPath to query any JSON. FHIRPath is designed to work with FHIR, but it's also possible to use FHIRPath with any kind of data. And if we go to FHIRPath.js implementation to the data tests, you can see here that that a lot of test data, just some plain objects. It's not valid FHIR resources, and FHIRPath still works pretty nice with it. For filtering, it is even emulate this stuff. So there is no such thing as functions resource type in FHIR, obviously, but FHIRPath work like this. So you can reuse FHIRPath even for this case when you are querying non-FHIR data. However, when we are talking about some legacy format, it's not of them are available in JSON or XML. For example, if you're working with some accounting information, you may face X12 protocol, or most likely you will face HL7v2. It is a text format. It is not JSON, so it seems that you can't use some path engine to query it, but you can do some kind of transformation. And if you're familiar with ADT, you see that it is like, if you're familiar with HL7, you can see that it is ADT message, and you can understand the meaning of each field, like its birth date and so on and so forth. So you can implement some kind of converter that represent this HL7v2 message as a JSON, and since it is JSON, you can query it with FHIRPath. Yeah. When we are talking about generating target data, obviously we're using FHIR structures, and we also can use structure definition to validate the result and check if it's correct or not. And finally, FHIR to FHIR. It is the most elegant example, because we can leverage FHIRPath without any doubt. Maybe I hope I convinced you that you can use FHIRPath not only for FHIR, but it's definitely worth to use FHIRPath with FHIR. And structure definition is a great way to validate FHIR resources, result of the mappers, and so on. So where do we need this kind of conversion? First of all, it is extraction process. As Lloyd mentioned, I participated in structured data capture implementation guide development as part of questionnaire work group. And the final step of each form is conversion from questionnaire response into a bundle transaction, and it is a perfect way of conversion from FHIR to FHIR, from questionnaire response to set of resources that you would like to create on your FHIR server. Another case is migrating from one version of FHIR to another. Like, for example, now you are R4 and you would like to migrate to R5, you need this kind of conversion. Finally, when you integrate with multiple sources, for example, with multiple EHRs in your pool, all the data, you need to somehow to harmonize, normalize, and save into your FHIR server. In this case, this transformation is still needed, because usually it's not that easy that you just take what external FHIR server provides you with and save it in the same format. You need some conversion, some fixes. So FHIR to FHIR conversion is also quite a useful thing. So let's see what tooling we already have, and what I am going to describe. So yeah, the first two I already mentioned, what path engine used and how result described and validated. But also it is important to understand who leads the development, other open source implementation, what type of DSL is it, and how it's licensed. Also, there are three criteria important for me. The first one is readability, is how mapper is safe, explanatory. Another important thing is how early you can spot an error, because the earlier you spot error, the better. And also there is top secret criteria that I will reveal at the end of this presentation. So here is example that I would like to demonstrate to you, that I will use to demonstrate all the mappers. So we have a questionnaire response that contain information about patient phone numbers. So we have a question with link ID, patient ID, that contains ID of the patient, and repeatable group of phones. Each phone has type and actual phone number. So we would like to convert this questionnaire response into bundle transaction that perform patch operation on patient resource and update telecom field with provided phone numbers and their types. So yeah, you can see like phone type home with value 4 zeros. So it should be like this. Okay, let's see. Let's start with first tool called FHIR Mapping Language. It is FHIR community-driven DSL designed for convert FHIR into any format. Mostly it used to convert FHIR into FHIR, but if you define structure definition for a target format, it could provide you some cool features like validation. Also, if you don't need validation, you may not specify target structure definition and generate whatever you want. The same thing with querying. So as you can see, it is external DSL, so it's brand new programming language with its own syntax, semantics. You need to build parser, elixir, all this stuff, but fortunately the grammar is provided by FHIR community, and you can use some kind of embedded query language where you can filter elements with some expression like where, and also you can leverage FHIRPath in some part when you can query some particular fields in the previously filtered values. Yeah. So as you can see, you need to be very familiar with FHIR mapping language to read this. It's not self-explanatory. So for me, it is not obvious what this mapper do, because I have to go to the documentation and read the whole documentation about FHIR mapping language to understand what's going on. Another thing is it's hard to understand how to work with lists, because it's like kind of hidden part. It works, but it's not like very obvious. Fortunately, it's fires errors when you do something wrong, because it's good, provide good validation experience. And if you would like to be 100% compliant with FHIR, you definitely need to use FHIR mapping language. But unfortunately, yeah. There are various implementations of FHIR mapping language, so please choose any of them. I will not focus on the details. You can find all information in the slide. Unfortunately, I don't like this idea of external DSL. Oh, it's a typo, sorry. I'm not a big fan of external DSL, because you have to learn new language, and also it's hard to read and so on. So when I started work on extraction, I decided to use some other mapping tool, and I ended up with using JUTE. JUTE is not designed to work with healthcare or with FHIR. It's kind of general tool for JSON conversion, but you can see that the number of lines of code is much less than in FHIR mapping language. And I like this idea of JUTE because basically you just need to describe the structure of your FHIR resource. If you're already familiar with FHIR, you can just leverage this knowledge. You don't need to learn something new. Also, it's pretty easy to embed values inside the data structure. Just provide like $, and after that you can write a JUTE expression. JUTE provides its own path engine, but it's also possible to extend it with any functionality. So I just introduced FHIRPath function and use it to query the data. So that's how it works. One of the important part of JUTE is that it's data DSL. So it's use data structure with some embedded functionality to become a kind of programming language, and it is safe to store this kind of mapper as a data for your code, because usually mappers, they are some kind of external stuff to your your application. Another example of data DSL is FHIR questionnaire. I think you are familiar with it. So it's the same approach. FHIR questionnaire is used to describe the form, and it's perfect example of data DSL, like JUTE. Yeah, everything is open source and available, so use it. As I mentioned on Dev Days, we had a lot of conversation about mappers, and I met guys from Outburn company. It is Israel company that's doing some work in FHIR and promoting it and so on. And they also faced issue with data mapping, and they provided their vision for this issue and introduced FUME. FUME is external DSL inspired by FISH. And it uses jsonata query language to query data. So if you are familiar with FISH, you can see that you can pretty easy read this stuff. Yeah. And on the right-hand side, it's jsonata queries. Not sure why they didn't use FHIRPath here, but I think it is possible to replace it. And in this case, it will be kind of perfect solution because it's leverage FISH from FHIR world and also can leverage FHIRPath. But right now with jsonata, and it's also fine. So if you like FISH a lot, please use FUME. It's also open source, all source code available, and you can just take it and use. Finally, on the Dev Days, Eric Pan introduced his approach to doing data mapping in a functional manner. It is this project called PDN, and again, it's pretty similar to what we see previously, to what we see when I talked about JUTE, FUME, and so on. So it just leverage structure of FHIR resource, and you can embed some Python construction, and PDN use jmespath query engine. Again, it would be much better to have FHIRPath here, but still you can query data with jmespath, and that's how you can generate the result. Again, I think it's pretty easy to read it, obviously, because you're using Python Python constructions, and for Python developers, it's a very straightforward way to read mappers. So I like this idea. But unfortunately, it's still a Python dictionary, so it do not provide any way to validate it, and also it uses some jmespath for querying. So I start thinking how it could be enhanced with more with Python tooling, more bind with FHIR, and I have a lot of tooling. I have FHIRPath implementation. Recently, we have implemented a FHIRPy types library that could generate pydantic schemas for based on structure definition. So I ended up with this solution. So it doesn't use FHIR dictionary. Instead of FHIR dictionary, it uses pydantic schemas. So everything is typed, and if you do some typo, like mistype some key or whatever, you will get an error during the type check. So you will get all errors on the very earlier stage. Also, if you need to convert not to FHIR but some other format, you don't need structure definition, you can still describe everything with pydantic. For the querying engine, I am using FHIRPath, and I am using Python DSL for FHIRPath. So it's a similar approach like SQL Alchemy introduced. You can with SQL Alchemy you can write SQL queries with Python, and I decided that I should write FHIRPath also with Python code. It's more convenient, and also it is possible to add some kind of validation layer on top of it and check this FHIRPath expression during the compile time. Unfortunately, this part is still work in progress, but we will finish it. And in this case, the whole mapper will be validated and checked that it uses only correct fields in resources and so on. Yeah. So this approach is pretty nice, but you have to use some specific programming language, because this kind of DSL, it is embedded DSL. It leverage basic construction of the source and of the source programming language, Python, for this particular case. Yeah. And also, it is not a data DSL. It is very important to be able to make mapper as external part of your code. If your system can distribute mappers as part of your source code, and you write these mappers, it's fine to use some embedded DSL. You can use like PDN, you can use tools from Beta Software and distribute these mappers as a Python code. But if mappers are external to your system, and it's most common case because it's a way of the system customization, you need a way to plug these mappers during in the runtime during the application running. In this case, data DSL works much better because it provides limited functionality. You will be safe with some attacks when you will get some malicious code along with the mapper code. So it's why it is important to have data DSL. And I start thinking how we can leverage all the knowledge from embedded Python DSL to create kind of perfect version of data DSL to query to build in mappers. I called the solution that I get FHIRPath Mapping Language. The name is still under development, so maybe we will find a new one. But what I decided to do, I think that we should reuse as many as we can from FHIR. And also, and during the discovery, I see that how XFHIR query was enhanced with embedded FHIRPath queries for purposes of SDC. And I think that it should be a way how we can do this, how we do mapping. And also, I would like to combine this approach with data structures. So liquid template mostly used for strings, but it's also possible to use it with data structures. As a result, I get this kind of mapper. So the structure is just a structure of FHIR resource or any target resource, and key may contain embedded liquid template. Inside the liquid template, it always a FHIRPath expression. So that's how we can generate the URL. And unfortunately, it's not so easy to handle cases like lists. I ended up with this solution. So if there is only one key, and this key is liquid expression, in this case, we treat it as a list, and each element will be executed along each element from this list, and result will be put to the telecom. There are other ideas how it could be done. If you're interested, you can go to the issue of this repository, and you will see some ideas and drafts how these issues and some other issues could be fixed. But this version is already working. I have interpreter in TypeScript that could do this kind of mapping, and I think it's pretty nice and convenient way to do the mappings. But there is one more advantage of data DSL that I didn't mention previously, and it was my top criteria secret, and one of the reasons why I decided to invent a kind of new mapping engine. So data DSL, they are LLM friendly, and obviously it's kind of buzzword that everybody used, and so am I. So for me, it's very important to be able to generate data using large language model for example, OpenAI, and let's see how I leverage it. I'm not going to proceed with the whole generator process. So I can just mention that this FHIR questionnaire was initially generated by OpenAI, and you can see like it do some weird stuff, like generate some weird codes for SNOMED, but you can check some speeches and videos from Josh Mandel where he described how you can enhance it, how you can validate FHIR resources and achieve like incredible result with generated FHIR data. So this part is already done, and it's not something brand new. So you can use OpenAI to generate questionnaire. But what mostly important for me is that this mapper, this mapper is also generated with OpenAI. So I just provided some high-level guidance to the OpenAI, and OpenAI is already aware of FHIR, about data structure, about FHIRPath, and it's just a combination of two existing elements that already exist in OpenAI, and it's trained with it. So the resulted mapper is still require some adjustments. So for example, in vaccine, you can see that it only populate code and system, and for some reason it not populate display, so I have to adjust it somewhere, like here for vaccine code. I have to change it, but it generate valid structure of the FHIR resource and adjust on some interesting stuff, like if there is no field like side effect, it generate text description, so it's pretty nice. And for some prototyping, this approach works pretty well. So yeah, basically that's what I wanted to share with you today. So thank you very much for listening, and please go through all GitHub repositories I mentioned today and give them a star, because it's important for open source contributor to see like that their work is appreciated. Thank you very much.
Thanks so much, Ilya. We've got only one question posted so far, which is, can you make the slides available?
Yes.
All right, so yeah, if you can just upload those into FeedLoop, I think there'd be a number of people who would be happy to have those so they can go chase the various hyperlinks and play with what you've built.
Yeah.
Awesome, thank you. If people have questions, feel free to post them in the Q&A. We are at time, but we've also got 15 minutes before the start of the next session. So I'm going to take advantage of you being here to ask a little bit and give people a chance to possibly type in some of their own. In looking at what you've built, this seems to be a mapping mechanism for the software developer type more than the data analyst type, who might be more useful to putting stuff into spreadsheets or whatever. This is more of a code-based, let's do data transformation. Do you think it's possible to put a user interface on top of this that might be more amenable to use by analysts? Or do you think that when we're looking at transformable mappings, executable mappings, that it's sort of inevitably going to require sort of a coder mindset and authoring environment to achieve that sort of conversion?
So when we're talking about user interface, it's always tricky, because from the one hand, you would like to provide all the variety of features, but it may end it like a lot of controls, very sophisticated, and in some cases it's much easier just to go and write mapper as a code. But yeah, it is obviously possible to generate, like if we're talking about this data structure, it's pretty easy to generate it from some kind of user interface. The tricky part is how we are going to describe the shape in some kind of UI editor, and also how we can query the source data. I did some experiments when, for example, you have your source format, and by clicking on specific field, it generates you some kind of FHIRPath, but it's still very experimental, but one day maybe it will be done. So there is no like technical restriction to build UI on top of any mapping engine I mentioned today, but it's more like UI, UX, and design challenges.
Okay. And I'll throw in one more because I can. So what you've built is sort of your own mapping language.
Yeah.
Is there a desire or an intention to bring it through the HL7 standards process, or do you envision it being possible to transform between FHIR mapping language and this? Just thinking about things from a perspective of getting support from multiple toolsmiths, incorporating it into Smile or FHIRly or any of those sort of product suites, sort of moving it from a really cool GitHub project into more of an official, this is a supported specification that the community is behind.
So I'm obviously keen to share all like my tooling with community, and if there will be a lot of interest to use this work in some like implementation guides or go through some official process of validating, I'm pretty happy to do it. Yeah, and I don't think that it is not possible to convert from one mapping language to another, because they should be compatible to each other. Maybe there are some advanced FHIR mapping language features that will be a challenge, but on the basic level, it should work nicely. Yeah, and regarding the implementation, so you can go to the repository and see the implementation, and all of them, they are pretty compact and simple, so it's much easier to implement to write code that could handle something like this, rather than implement the whole FHIR mapping language engine. Yeah, it's much easier to handle this kind of stuff.
Yeah, I can definitely see that. All right, I'm not seeing any additional questions posted. Obviously, Ilya's contact information is there. If after you've had a chance to poke around, you have more questions, you can certainly reach out to him, or you can reach out to him through Feedloop as well. Thank you, Ilya, for getting up early. Ilya is based in Australia, so yeah, earlier morning for him than it is for us. And yeah, thanks for showing what you've built, and hopefully some of us can start taking advantage of it.
Thank you.
Next up is sort of our closing for the day, a summary of what's been happening everywhere that you might not have been able to keep track of. And then there's tomorrow. So thanks all for coming to the session, and we will talk to you. We'll see you at the closing, and we will talk to you tomorrow as well.